Copyright 2014 Math Diagnostics and Intervention, all rights reserved. We're going to take a look at a special case of one-step equations, and what we're going to look at is we're going to look at the situation where we have x plus 3 equals 7. Now many of you can do this in your head and you can say, well, obviously x is equal to 4 because we know that 4 plus 3 is equal to 7. But in algebra, it's important to understand why things work and to be able to undo them for later processes and later problems, more difficult problems. And remember that we have to get the x equal to something. Our goal when we're done with this is we want to say x equals a number. So let's take a look at what's really happening here. What we have is we have this box of x, and that's what we're trying to find out what's inside the box. And then we have these plus 3. Each one of those plus signs represents a 1. And that's equal to 7. So I have the picture representation of x plus 3 equals 7. So in order to get the x by itself, because remember our goal is to get x equal to something, x equals to a number, and in order to get the x by itself we need to get rid of the plus 3 over here. Well, in order to get rid of that plus 3 we need to take away 3. We need to subtract 3. And that's exactly what we do. We subtract 3 from here and we subtract 3 from here. Or add negative 3, either way. These end up being 0. So we just have our box of x left over. Equals, well, those negatives get rid of 3 of my positives. That's 0, and I have 4 positives left. So in this case here, there's my picture of x equals 4. And that's what we're going to do algebraically or symbolically. We're going to take a look at x plus 3 equals 7, and we're going to subtract 3 from both sides of the equation. And we end up with x plus 0 equals 4. And of course x plus 0 is just x equals 4. Now we can get other versions of this type of problem. We can end up with something like x minus 8 equals negative 3. And basically what I have going on here is I've got this box of x. And remember that we can write subtraction problems as addition problems by keep, add, change. So really what I have going on here is I've got this x plus negative 8. X plus negative 8 is equal to negative 3. Well, I've got to get the x by itself, so in order to do that I'm going to add 8 positives. Got to add 8 to make that 0. But whatever I do to one side of the equation, I have to do to the other side of the equation. And my 3 negatives and 3 of my 8 positives add out to 0. So we end up with x plus 0, or just x, equals 5. So what we're going to do, back to the original equation, x minus 8 equals negative 3. We're going to add 8 to both sides. And we end up with x equals 5. Negative 3 plus 8 is 5. If you remember this and manage your details, you should have very little problem, very little difficulty with these one-step equations.